Welcome to our video assignment. This is Team Blazers with Katie Kirchhoff, Lamoine Tatum, and Carolyn Willis. Today we will be explaining how to do algebraic tests for symmetry. So graphs can have symmetry with respect to the x-axis, which is this graph right here, because if you flipped it over the x-axis, these would be overlapping. They can have symmetry with respect to the y-axis, which is number 2 here, or to the origin.
Okay, this is Katie Kirchhoff, and I'll teach you about the x-axis symmetry. The graph of an equation is symmetric with respect to the x-axis if replacing y with negative y yields an equivalent equation. So if we take this equation, y equals x squared minus x to the fourth plus 2, and replace y with negative 2. So negative y equals x squared minus 6x to the fourth plus 2, you can see that both equations are not equivalent. Now if we take the equation y to the fourth plus x squared minus 10x equals 0, and replace y with negative y. Negative y becomes y plus x squared minus 10x equals 0. Because it is to the fourth power. So these two equations are the same. That is how you check for x-axis symmetry.
Hey guys, this is Lamoine Tatum, and I will be teaching you about the y-axis of symmetry. So our equation is y equals x squared minus 6x to the fourth plus 2. The graph of an equation is symmetric with respect to the y-axis if replacing x with negative x yields an equivalent equation. So our first step will be to replace all the x's with negative x. So we have y equals negative x, and make sure you put them in parentheses, otherwise that will mess up the whole equation. Minus 6 negative x to the fourth plus 2. Because the exponents are even, they will be positive. So now we have x squared minus 6x to the fourth plus 2. As you can see, both of these equations are the same. After simplifying, we get the exact same equation. Therefore, there is symmetry about the y-axis. And to prove to you that this is true, we are going to put it on a graphing calculator. So you see the equation, the original equation, x squared minus x to the fourth plus 2. If we graph it, you will see that it is that. And then if we put in our new equation, negative x squared minus 6 to the fourth plus 2, that will give us the same equation, or the same graph.
Okay, for example 3, we have origin symmetry, and this is Carolyn Willis who will describe it to you. So this is the equation that we're going to be testing for if it has origin symmetry or not. And again, to just define origin symmetry, it means that every single part of this line is going to have a matching part, the same distance from the origin, which is 0, 0 right here, but it's going to be in the opposite direction. So right here we have the point xy, and that same point opposite is going to be negative x, negative y. So here's our equation, y equals 1 over x. So our first step is going to be replacing negative x with y or x with a negative x and y with a negative y, because the graph of an equation is symmetric with respect to the origin if replacing x with negative x and y with negative y yields an equivalent equation. So we're going to do negative y equals 1 over negative x. I'll put parentheses over there to make sure. And then what we're going to do next is multiply both sides by negative 1, because y can't be negative if we're going to be plugging it in anywhere. So here's the equation we had before, and we're just going to multiply both sides by negative 1. So that equation is going to come out the exact same way as our first equation we started with. And so because they are equivalent equations, we do have origin symmetry because they match. So we're going to write yes.